question that we're sometimes asked is about exhaust systems. Why is it that there are exhaust gaskets that are shown in the parts manual and yet my airplane doesn't have exhaust gaskets on it? The answer is because there are actually two different styles of exhaust system. The most common system that you'll find is similar to this. This is a number 4 exhaust pipe from a Waco UPF7 system. And if you look at the exhaust flange here that bolts to the exhaust elbow, the pipe protrudes through the exhaust flange about 1/2 to 3/4 of an inch. Now this is a system you'll see most often on all of the Stearmans have this system, and a lot of the Wacos have this system. This is a 65-degree elbow for a Continental W670 engine, and the pipe nestles into the elbow. And what you'll notice is that this protrusion of the pipe actually goes inside the elbow, and inside the elbow there is a steel liner in there. This is one of the liners that is out. The elbow is heated, and then the liner is shrunk into it, and so this actually is the sealing mechanism on this type of exhaust system. There is no gasket that goes on this style where the pipe protrudes through the flange. Now on the Cessna 190s and on some of the aftermarket systems, the pipe won't protrude through the flange. The pipe comes down and is flush with the flange. In that case, you use this Continental exhaust gasket, which just slips over the studs on the exhaust elbow, and then the pipe slips into that. It's not necessary to have the steel liner in there. Doesn't hurt it if it's in there, but it's not necessary if your pipe does not protrude through the flange. Now, one other question that we're often asked is about gasket cement. Everybody has their favorite gasket cement. Permatex number 2 was the standard for years and years and years. The stuff that we've used for the past few years is actually a Yamaha motorcycle gasket cement called Yamabond 4. Yamaha puts their entire engine together without gaskets, just using Yamabond 4. Recently, within the last year or so, they discontinued Yamabond 4 and went to a different product. We weren't as happy with that product, so what we've switched to is actually 1194 3-bond gasket cement, which I think is just Yamabond 4 in a different package. Smells the same, acts the same, and so 3-bond 4. We actually buy this from the Yamaha motorcycle shop. They said, gee, we like this a lot better than the replacement for Yamabond 4, so that's what they're using. But it's a non-hardening gasket cement. Works very, very well with sealing up gaskets where you need that. I'd like to visit for a couple of minutes about wiring harnesses. There are several options that are available. The earliest of the Continental engines ran an unshielded wiring harness. The ones for the Wacos most normally had a very small ignition ring that bolted into these 4 places on the nose case, and that ring carried 7mm unshielded wire in a couple of aluminum tubes that came back along the power case and back to the magnetos. Those little aluminum rings are pretty scarce, and so you don't see them very often anymore, but they make a very attractive ignition ring if you can find one. Now, when the radios began to be available in the 1940s, and they began to put shielded ignition systems on the Wacos, they had a similar small ring, but then they had brass conduits that came out and large brass conduits that came back. So, but both of them were small ignition rings that mounted tucked in close to the nose case and looked right for the engine. Now, in an attempt to duplicate that without the correct parts, people have often put the Jacobs ring on the front of the Continental. This is a chrome Jacobs ring, and you'll see that though it does mount up there, it really doesn't fit the nose case very well, and there's not a very good way to mount it, so you wind up running straps back from those locations. And though this harness will work fine on the Continental engine, in my opinion, it doesn't really look right, and looks like something that was kind of tacked on as an afterthought. Now we can go around back of the engine and I'll show you the rear harnesses that have been used over the years. If you go to your Continental overhaul and parts manual and look up an unshielded ignition harness in the parts manual, what you'll find is this loom that is on the back of this engine. It goes from cylinder number 7 past cylinder number 1 over to cylinder number 2. And this thing originally carried 7mm unshielded wire, used the Connecticut terminals for the unshielded spark plugs, and then came back and went into the magnetos. This harness is often called a steerman harness, though that's really a misnomer, because this harness was used on everything that Continental built with an unshielded system after 1941. So it was used on Fairchilds, and anything that got a Continental got this unshielded harness. Now this particular harness that you're looking at here is a shielded harness. We obtained approval several years ago to take this original loom, strip all the unshielded wire out of it, and run shielded wire through it. And so it looks very original, looks like an original W670 unshielded harness, but it is a shielded harness. You can tell, well, one of the only ways that you can tell is because it has the shielded spark plug elbows on the end, so that, and then it will have shielded spark plugs, and that's the dead giveaway that you're looking at a shielded harness here. But it looks very original, tucks back in where it was supposed to on the Continental, and I like this design really well. We put the original friction tape on the wires, on the shielded wires, so it truly does look like the original unshielded system. Now, instead of the brass grommets that would go into the magneto shields here, or instead of the rubber grommets, which were the originals, we make these brass grommets, which we can then run all the shielding through and solder it on the back side. That way there is a good electrical ground here, and there is a good electrical ground on the other end where it threads onto the spark plug. Now this is something that we've had people make up shielded systems in the field using shielded wire, and they grounded the lead at the spark plug as it should be, but then they just ran the leads back through the original rubber grommet, thinking that if it was grounded here it would be grounded everywhere. Doesn't work that way. You'll wind up with lots and lots of radio noise. Has to be grounded on both ends, and so this grommet needs to be solidly grounded to the shields, which need to be solidly grounded to the magneto, which needs to be solidly grounded to the engine. So there has to be a continuous path for ground, or you'll wind up with radio noise. If you wind up with radio noise with a shielded system, the first thing that I would look for is the possibility of paint that is between any of these things that need to be grounded together. They need to be raw metal, contacting raw metal, no paint in between anything, or you'll wind up with a high resistance connection, and as a result you'll wind up with radio noise. Now the other rear shielded system that you will sometimes see on the Continental engine is the Continental tank harness, and I have an example of that here. This is a Continental tank harness, and you can see where it would bolt up, and with the magneto blocks going into the magnetos. The problem with this harness is that these elbows get very, very close to the exhaust system on a Stearman or a Waco. So close that it cooks the wires. And so we have taken harnesses apart, the tank style harness apart, and found that the wire was good everywhere except right in the elbow. And this elbow was only running about 1.5 inches away from the exhaust system, and it was just brittle right in that elbow area. So on the tank engines, the exhaust was routed a different direction and didn't run so close. But on the aircraft engines, it runs very, very close to these elbows and just absolutely bakes the wires in there. So not an ideal situation for an ignition system. An issue that we receive a lot of phone calls about is troubleshooting oil leaks, trying to locate where the oil leak is coming from. We have mechanics and we have owners that call frustrated and say, you know, I've tried and tried and tried to find this oil leak, but I just can't chase it down. How do I determine where the oil is coming from? Now, you know that a very small quantity of hot oil will go a long, long way. I mean, a teaspoon will seemingly cover your airplane. And you can have an oil leak that is happening here, but because of the airflow and the way the prop blast is whipping the air around, the oil winds up here, and so you're looking for an oil leak here that is actually down here, or you can have a leak that's coming out of this rocker shaft that winds up dripping off of the magneto. And so it's sometimes really tough to troubleshoot these things and figure out where is that oil coming from. So I'll show you something that we have developed just over time that has helped us to chase down these things as we're trying to locate these oil leaks. It's very simple. All you need is a roll of paper towels and a roll of masking tape. And what we're going to do is we're going to try to determine, best we can tell, where is the oil coming from. And the best way to start this is by washing down the engine. Get the thing clean. Get some Stoddard solvent, wash it off, blow it dry, and get it clean. Then, without flying it, run the engine up until it's warm and look for oil leaks, because there'll be a whole lot less wind blowing things around at that point. Once you've determined where you think the oil is coming from, the general area, let's say we think that it's somewhere up in this area, we wash it down again, blow it dry, make sure that it's nice and dry and clean and there's not anything there, and then we tear off some paper towel. And we take this paper towel and we fold it up and we make ourselves a little diaper. And we say, you know, I think possibly that our oil is coming from a pushrod tube. And so we take a piece of tape and we take our little diaper and we say, you know, I think maybe it's coming from this pushrod tube. And so we'll take our diaper and we'll wrap it around the pushrod tube, and then we'll take our tape and we'll tape it in place. And we'll get that nailed down real good so that the wind from the prop blast is not going to blow this thing off. And we'll tape it to the cylinder real good there. Okay, and then we say, well, we've got a rocker shaft here. Possibly it's coming from that rocker shaft because the rocker shaft's pretty close to the pushrod tube. So let's make another little diaper. We'll make it appropriately sized for that other location, and we'll put that up there, and we'll tape that down right here. Okay, now we've got it diapered in both of those locations. And so now we can run the engine again. If at the end of our run we find oil all over the place, what we've just proven is that the leak was neither there nor there. Because if the leak was in one of those locations, it would have been caught by the little diaper and would not have gotten out. So if we've still got oil all over the place, we know that we missed it and we weren't looking in the right place. However, if after running it, and possibly even flying it, there's no problem with doing a test flight with these things on there. We're not going to cause the paper towel to burst into flames. So if after flying it or test running it, we determine that we really don't have an oil leak anymore, then what we can do is we can carefully peel up our little diapers, and wherever the oil leak was, we're going to have oil right there in that location, because we trapped it. It couldn't go anywhere, and we're going to find our oil leak. You may have to tape up several places on the engine in order to find it, but so far it's been a foolproof way of chasing down oil leaks that are seemingly impossible to find otherwise.